In the last video, we looked at several different transformations of functions and how they affect our graph. We had vertical shifts up and down, horizontal shifts left and right. Then we had vertical stretches and compressions and horizontal stretches and compressions. And the key point we said was, if you do something outside of your function, it affects it vertically. If you do something inside of your function, it affects it horizontally. There's two more transformations we want to look at. So suppose we have y equals negative x squared. What would the graph of that look like? Well, keep in mind the negative is outside of the square, which we said means it should affect it vertically. Plot a few points to get an idea of what's going on. If I plug in 0, I get 0 squared, which is 0, and then make it negative, which is still 0. If I plug in 1, I get 1 squared, which is 1, and then I make it negative, so it's down here. If I plug in 2, I get 2 squared, which is 4, then I make it negative, so I get negative 4, which is down here. We know this is symmetric, so then it will be down here. And essentially, what did I do to my original graph? I flipped it here. One point about this is, essentially, I reflected it across the x-axis. So if I multiply by a negative outside of my function, I flip it across the x-axis. Again, like I said in the last video, the terminology can be confusing because you tend to think if I flip across the x-axis, I'm affecting it horizontally because the x-axis is horizontal. From a mathematical perspective, in order to flip across this x-axis, you actually have to take your graph and flip it this way, which is flipping it vertically, which is why we say the negative is outside, so this is a vertical reflection. Across the x-axis. So if I have y equals negative absolute value of x, I can graph that really quickly. I know the regular absolute value graph. Negative on the outside will just reflect it. It'll look like that, and I'm done. There's one more transformation we want to look at. Based on the last video, we can tell everything we can do vertically, we can also do horizontally. So, I can put a negative on the inside, and I can put it on the outside. So for this one, we'll do this, negative x cubed. Again, we understand here the negative is on the inside of the function, inside the cube, which means it should affect it horizontally. Given that the negative on the outside caused a reflection, it would seem logical that this will cause a reflection that's horizontal. So we just want to check it to make sure. If I plug in 1, or if I plug in 0 to start, I guess, I'm going to get 0 cubed, which is 0. If I plug in 1, I get negative 1. Then I cube that, which is negative 1. If I plug in 2, I get negative 2, which cubed is negative 8. So now I can tell it looks like it's doing that. If I plug in negative 1, I get negative 1, which is positive 1, cubed, which is 1. If I plug in negative 2, I get negative 2, which is positive 2, cubed, which is 8, and now we can see it's doing that. And clearly, if you remember the original cubic graph, which looked like this graph is essentially flipped across the y-axis right here. I know it looks, because of the graph, it looks like it's also flipped across the x-axis, but in this case, it's flipped across the y-axis. So what we say is, this is a horizontal reflection. Again, the idea being, you're going across the y-axis, but essentially, you're taking your graph and flipping it this way, which is flipping it horizontally. As far as it goes, that's all the transformations. But now we actually want to use them to graph some functions out. So we're just going to do a couple of examples so we can see how this works. So suppose I have y equals 2 times x plus 3 squared minus 5. I want to graph that, so I say, what is my original function? It's clearly x squared. And then what are all my transformations? Negative 5 on the outside means I go down 5. Plus 3 on the inside means I go left 3. Remember, that's horizontal, so it's opposite direction, so I go left 3. 2 on the outside will be a vertical stretch by 2, which will just make my graph get bigger a little bit faster. So now graph it. Let's see, I would start my quadratic at 0, 0. I'll go left 3, down 5, and then my normal parabola will look like this. So since this one is stretched, I'll make it a little bit thinner. And I'll label this point negative 3, negative 5. And there we go. And that's the ultimate goal for you guys, to be able to see a function written like this, immediately identify the basic function I care about, in this case x squared, all the different transformations, and then plot your graph without your calculator. So, suppose I have y equals negative 3 absolute value of x minus 2 plus 4. I want to graph that. So let's see, if I list out my transformations, the plus 4 will make me go up 4. The negative 2 will make me go right 2. The 3 will stretch vertically by 3. And keep in mind, the negative is also a transformation. That will reflect me across the x-axis. It's a vertical reflection which goes across the x-axis. So now put all this together. One thing I would point out, be careful here, the plus 4, the thing at the end on the outside, do at the very end of your graph, otherwise your transformations won't work out correctly. So here, I shift right 2, then I'm going to stretch it by 3, which will make it thinner, then I'm going to reflect it, which will make it go downwards, then I'll go up 4. So it will look like that. Just be careful when you do this, don't assume, oh, I go 2 right, 4 up, and then the reflection sends me down here. This shift is done at the end after the reflection, so either find the vertex, the point you care about, and then just reflect around that point when you do this reflection, or do all these transformations and then add 4 at the end. They have to be done in the right order or your graph won't be correct. We're going to do one more just so you guys have as many examples as possible to go by. So suppose we have f of x equals negative 2 absolute value of x minus 1 plus 2. So we know what the absolute value with the square root function looks like. Parabola turned on its side. It's in your book. So for my reflections, let's see, my transformations, that will go up 2. This minus will go right 1. This 2 will stretch by 2 vertically. This negative will reflect across the x-axis. And again, we'll make sure to do the reflection before that, or just reflect around the point that we care about at the end. So let's see. I go right 1, I go up 2, so this is my starting point. I'm going to reflect around that point. The stretch by 2 will just make this get bigger faster. So keep in mind, without the negative, this would just kind of look like this. The square root graph shifted right 1 up 2 and getting bigger a little bit faster. The negative will reflect it, but don't reflect it down here, reflect it here. So this is my graph right here. Okay, good. Like I said, the goal here was to give you guys an understanding of all the different transformations, as well as let you see several of them worked out. As far as how you choose to graph them, keep in mind, for your homework, if you want to use your graphing calculator or your phone as a guide, that's completely fine. On your exam, you won't have access to that. So you need to know each of these transformations and be able to understand what each of them is and what it does, and then use that to get your final graph.